Okay, today we're going to go over 8.3 number 1, which is quadratic functions in the form y equals ax squared plus bx plus c. Up to this point in chapter 8, we just introduced you to what we called vertex form. Okay, vertex form was y equals a, and then in parentheses we had x minus h quantity squared plus k. H and K were your vertex, and what did the letter A tell us? Okay, the letter A told us what direction the parabola was going. If A was a positive value, then the parabola was going to open up. If A was a negative value, then the parabola was going to open down. Also, that A value, when it was greater than 1, the parabola got much skinnier. If it was a 2 or a 3, it got thinner. And if that A value was a fraction, like less than 1, like a half or a third, then that parabola would get much wider. Okay? So we're going to work today on standard form. So standard form for our quadratic functions looks like this. You notice that you have an A value as well. That A value serves as the same purpose. They do the same thing. When this A value is positive, your parabola is going to open up. When this A value is negative, your parabola is going to open down. When that value is greater than 1, your parabola is going to get thin, skinny. If you have a fraction here, you're going to see that parabola get wider. Okay, the things that we wanted to know about the vertex form, we asked you where the vertex was. Okay, we had to find the vertex. We also had to find the axis of symmetry. Now, when something is in standard form, okay, our axis of symmetry, remember that's a line, it's going to be x equals. And when it's in standard form, we have a formula for finding the axis of symmetry. That formula is x equals the opposite of b over 2 times a. Okay, you'll notice that you've got a coefficient that's a coefficient that's a b, and a constant term at the end that's c. Those are your a, b, and c values. When I plug those in, if I take the opposite of b, so you're going to take the opposite sign, and you're going to divide it by 2 times the a value. That will give you the axis of symmetry. And the connection between the axis of symmetry and the vertex is that whatever x value we had here, that was going to go in for that same value goes in for the vertex. Now we'll have to find what goes with that value, but we'll show you how to do that. Okay, and then the last thing that you're going to be asked to do is to find the y-intercept. And the y-intercept is located on the y-axis, so we know that the y-intercept has an x-coordinate of 0. And if I were to plug a 0 into this formula for the x, the only thing that's left to calculate is the c value. So the y-intercept is always 0, c. Whatever your constant value is at the end, that's where your y-intercept is at. Okay, so let's see how this works with an equation. I'm going to use y equals x squared plus 2x plus 4. On this worksheet, you're going to be given an equation in standard form. Okay, again, this is called standard form, like in chapter 7, where we started with our greatest exponent, worked our way down. That's why we call it standard form. And these are the things you're going to be asked to find. So we want to start with the axis of symmetry. Okay, I'm going to use that formula that I just gave you, which is the opposite of b over 2a. So when I look at this equation, my a value is the coefficient in front of the x squared. So a is going to be 1, b is going to be the coefficient in front of the x, so it would be 2, and my c value is the constant, or 4. So those are my a, b, and c values for this particular equation. So my axis of symmetry, give myself a little bit more room, okay, is the opposite of b, so the opposite of 2 is negative 2. X equals negative 2 over 2 times my a value. My a value is 1. So I'm going to evaluate this, negative 2 over 2. I get negative 1. So my axis of symmetry is going to be x equals negative 1. Okay, to find the vertex, we know that the vertex always lies on the axis of symmetry. So if the x equals -1, we know that x is going to equal -1 on the vertex. To find the y-coordinate that goes with it, you're going to just plug it in. You're going to say y equals, if I plug -1 in here, I get -1 squared plus 2 times -1 plus 4. And you're going to evaluate that. -1 squared is +1. This would be -2 plus 4. -1 plus 4, I would get a y value of 3. So my vertex is going to be located at -1, 3. And then my y-intercept, okay, that's always going to be with a 0, because it's on the y-axis. All points on the y-axis have an x-coordinate of 0. If I were to plug 0 in here, you notice these are going to drop out. It's always your constant term. Okay, so on your worksheet today, we want you to come up with 3 things. We're going to give you an equation. We want you to write the axis of symmetry, the vertex, and the y-intercept. And when we get to the second section of this unit, we will graph those features.